Welcome you to my YouTube channel. In this video, I'm going to discuss two JEE questions from solution lesson. We are going to see how to calculate the molality of dissolved oxygen in seawater. And the next question that we are going to discuss is the mole fraction of A and B in vapor phase versus liquid phase. Let us see the first question. Seawater is a 6 molarity solution of NaCl and has the density 2 gram per ml. The concentration of dissolved oxygen in seawater is given as 5.8 parts per million. You are asked to find out what's the molality of dissolved oxygen in seawater. So the given data are molar mass of NaCl is given 58.5 gram per mole and molar mass of oxygen is given 32 gram per mole. The answer you have to express in terms of 10 power minus 4 mole per kg. So you are asked to find out what is the value of X. To find out molality, you know that the formula that we are going to use is mass of oxygen by 32. It is nothing but number of moles, mass by molecular mass, divided by mass of solvent in kg. Let us analyze the data given. We know that 6 molarity in NaCl has 6 mole in 1 liter. Then the density is given as 2 gram per ml. If I convert the ml into liter, I will be getting 2000 gram per liter. Now, if I find what is the mass of NaCl present in the given seawater, so I need to do 6 into 58.5. To find out the mass of the solution, what we are going to do is 1000 ml into the density. Okay, so the density value is given as 2 gram per ml. So the mass of 1 liter of seawater is 2000 gram. Now let us calculate mass of oxygen in terms of gram. So this is the formula I'm going to use it. Parts per million is equal to mass of oxygen divided by mass of solution into 10 power 6. By rearranging this equation, I will be getting 5.8 into 2000 divided by 10 power 6. I will get answer in terms of grams. Then what I have to do is I'll have to calculate how many moles of oxygen present in 1.16 into 10 power minus 2 gram. So mass of oxygen divided by molecular mass, I have calculated 3.625 into 10 power minus 4 moles. Then, in order to calculate molality, I need to know the mass of solvent, right? So we know that the mass of NaCl present in 6 molar solution is 351 gram. And then if you want to calculate the mass of solvent, so what I need to do, mass of solution minus mass of NaCl. So what I have calculated is 1.649 kilogram. So what I need to simply do, I have to substitute the values. So the molality is equal to number of moles divided by mass of solvent in terms of kg. So number of moles what we have calculated is 3.625 into 10 to the power minus 4 divided by 1.649. The value I have calculated is 2.197 into 10 power minus 4. So here is the value of Ex. So if you convert it into the nearest integer, you will get the answer as 2. Let's move on to the next question. So you have a liquid A and B. They form ideal solution. The vapor pressure of liquid A and B are given as 350 and 750 mmHg. And if XA and XB are the mole fraction of A and B in the solution, YA and YB are mole fraction of XA, A and B in the vapor phase, then you are asked to find out in which way XA and XB is related to YA and YB. This is what you are going to find out. Let us now fetch the data as given. PA naught. So this 350 is given as PA naught, and then 750 is the vapor pressure of B, and then XA and XB are mole fractions which are present in solution, and then YA and YB or mole fraction in vapor phase. Okay. What I have to do is I'm going to apply Raoult's law, PA is equal to XA into PA naught. And then if you want to calculate what is the vapor pressure of component B in the solution, what I need to use XB into PV naught. You are going to calculate total pressure. Total pressure can be calculated from PA plus PB formula. And then the value of PA is XA, PA naught, and the value of PB is XB, PV naught. Okay. So then when you apply the Dalton's law to calculate the mole fraction in vapor phase, this is the formula I'm going to use it. PA divided by P total. So to calculate PA, I need to take XA into PA naught. And to calculate PV, I need to use PV divided by P total. So what I now do is I'm going to take the ratio of these two equations. So YA divided by YB. So when you do the ratio P total get cancelled, you get the answer as PA by PB. The value of PA, you know that it is XA into PA naught. The value of PB is XB into PB naught. Okay. So now if you substitute the value of PA naught and PB naught in this formula, and then if you simplify it, you will get the answer as 0.47. The value of YA and YB is obtained when you multiply XA and XB with this 0.47, which indicates that XA and XB is greater than YA and YB. So this is your option. Thanks for watching.